Hey guys, one of my favorite features in BGP is this feature called Conditional Advertisements. Now, I personally think that this is really, really cool. So let me illustrate how we're going to essentially set up our network, and in doing that, I will go ahead and explain how this feature works and how we can use it to our advantage. So let's say that this guy here, router 2, is going to be our ISP1, and let's say that R3 is going to be our ISP2, okay? Now, R1 is going to be sitting over at the edge of our network, and we are going to form an eBGP relationship between our service providers, okay? We will be an autonomous system, let's say 65,001, and these guys will be 65,002 and 65,003, okay? So that's how we're going to set this up. Now, in the real world, you might have a perfectly good adjacency with your service provider, right? You may say, hey, these guys are perfectly functional. We have an adjacency. We're good to go. However, your service provider may have a problem on the back end. So what happens if we say, look, I don't want, if my service provider has a problem, I want to stop advertising my prefixes to my service provider that's having a problem. So in other words, it's this dynamic advertisement, or as we call it, conditional advertisement to your ISP. You're saying, look, if you have a problem, I want to stop advertising my prefixes to you. You can also do the other way around. You can say, look, if you have a problem, I want to start advertising my prefixes somewhere else. So let's bring this to the next level. Let's say R2 has a 1 gig link and maybe R3 has a 100 meg link. And maybe you don't ever really want to use your backup link. You're not really interested in multipathing. You're not really interested in ever sending production traffic over R3 unless, of course, R2 or, ISP1 has a problem. So you say to yourself, look, I want to normally, on a regular basis, I want to advertise my prefixes out to ISP1, and I want ISP1 to be used for all of my traffic no matter what. However, if for some reason on my service provider backend, if he should lose a link, if he should lose an adjacency, if a router should go down, if for some reason my service provider has a problem, I want to be able to automatically detect that. I want to stop advertising my prefixes to my service provider, and I want to start advertising my prefixes out to my secondary service provider. So you can build in this dynamic advertisement by using the conditional advertisement. So basically, what we're going to do is we're going to look for this prefix inside of R1. So basically what we're going to do is what I just said. So we're going to build what we call an advertise map. Okay, so let me just jot this down here so that you guys don't forget. So we're going to build this advertise map. And what that really is just a route map that basically says advertise this. That's all it does. All it is a route map that says advertise these prefixes, okay? And of course, it's based on a prefix list or an ACL or whatever makes you happy. We'll probably just use a simple ACL because we're just labbing, but you can use, again, whatever your requirement is and in whatever you're doing. Now, the advertise map is going to look for two sets of other conditions, and those conditions are called exist or non-exist. Now, what's the difference between these? Well, it's very, very simple. The exist is basically, does this exist? Does this route exist? Okay? If this route exists, we are going to perform this particular action. So basically what we're going to do is we're going to say, okay, we're going to say neighbor 2.2.2.2 advertise map this, and it's going to be, maybe some loopback addresses that we have hanging over here on the end of R3. And it's going to say advertise these prefixes as long as this route or prefix exists. Okay? Now, then what we'll do is we'll say neighbor 3.3.3 non-exist. And so what that's going to do is that's again going to look for the same 1040 prefix and say, look, advertise whatever's in our advertise map to R3, but only when these prefixes do not exist in our routing table. So it's a very, very cool feature to be able to set up this dynamic advertisement inside of BGP and be able to tell BGP who and when and why you want to advertise specific prefixes to a neighbor based on the existence of another prefix. Now, just to bring this into the real world, this address might be something like Google, or Facebook, or something that is not ever going to go away, and something that your service provider is always going to advertise to you. And so if that advertisement goes away from your neighbor, then you start advertising your prefixes somewhere else altogether. Okay, so let's go ahead, let's clear the screen. And let me bring up, we'll bring up our CLI, and we'll go ahead and get this configured. What we're going to do is we're just going to use our, we're not going to mess around with loopback zeros. What we're going to do is just basically form with our directly connected interfaces. So we'll say router BGP 65001, BGP router ID 1.1.1. We'll say neighbor 10.1.2.2, and his remote autonomous system is going to be 65,002. We'll go ahead and say redistribute connected. We'll say neighbor 10.1.3.3, and his remote AS is going to be 65,003. Do show run section router BGP. So at this point, we should be able to form a pretty simple adjacency here between R1, 2, and 3. Let's wake up R2. Config T router BGP 65,002. Oops. BGP 65,002, BGP router ID 2.2.2, neighbor 10.1.2.1, remote 65,001. And what we'll do is go ahead and say redistribute connected. So do show run section router BGP, and that should do it. So a neighborship comes up. May take a couple 30 seconds here for us to advertise our prefixes. Router BGP 65,003, I believe is what we said. BGP router ID 3.3.3, redistribute connected, neighbor 10.1.3.1, and we're going to say remote 65,001. Let's control C out. All right, so we should have adjacencies that come up in theory. Let's see here. This doesn't look to be, there we go. Sometimes I just don't have patience. So let's say show IP BGP summary. Let's see what we get. We have not gotten any advertisements yet from our neighbors. And we know that BGP, again, is not the fastest routing protocol on the face of planet Earth. And so just to recap again while we wait, of course, I have to find something to say in the meantime, is what we're going to do is we're going to basically look for this prefix here. And we're going to go ahead and, you know what, while we wait, we can go ahead and build it anyway. And we're going to say, look, when this exists, so if exist, okay, then advertise. Okay, so let's go ahead and let's actually build that first. So on R1, first thing we're going to do is we're going to build an access list that matches the network that we're looking for. Again, you can build a prefix list. You can do essentially whatever you want. Okay, so I'm going to say access list permit, and I'm going to say 10.2.4.0, 0.0.0.255, because I'm looking for a /24. Okay, next thing I'm going to do is I'm going to create a route map. So I'm going to say route map, and I'm going to call it advertise. Okay, actually, no, that's not true. It's going to be exist. Permit 10. Now, this exist map, all it's going to do is say match IP address, and it's going to go ahead and say 1. Okay, we're not going to apply any other prefixes to it. We're not going to do, we're not going to apply any other prefixes to it. We're not going to go ahead and apply attributes to it. This is all we're going to do. Do show run section route - map. So all we're doing is we're saying, look, I'm looking for this particular prefix, okay? Now what I'm going to do is I'm going to go ahead and I'm going to create a route map that says advertise. Now, that advertise route map is basically going to say or list the prefixes that I want to advertise. So if I say do show IP interface brief E assigned, you can see here that I have my 3 loopback addresses that I can play with. And what I'm going to do is I'm just going to pick on one, okay? So we'll pick on loopback 1. So all I'm going to do is say, look, if for whatever reason, as long as I have a route to this prefix, to this network, I want to advertise this network out to R2. So if we say do show IP BGP summary right now, we should be receiving prefixes. If we head over to R2 and say show IP route BGP, you can see that we have a network 192.168.1. Show IP BGP, and you can see here 192.168.1.1. So we have that this route in our routing table, okay? And don't forget, do show run section router BGP. We've gone ahead and said redistribute connected. So all of our connected interfaces should be pumped into BGP, okay? So now let's create our route map, and I'm going to say advertise, and we'll say permit 10. Again, we don't have to do that. It should be automagic. And I'm going to say match IP address, and I'm going to say 2. Now, we have to create this ACL, so access list 2, permit, we'll say host 192.168.1.1, because don't forget, we're just going to advertise that one network, that one prefix, okay? Now, the last thing we're going to do show run section router BGP, is I'm going to go into my BGP process, and I have to apply this per neighbor. So what I'm going to do is I'm going to go in and I'm going to say neighbor 10122, that's my neighbor of router 2, and I'm going to use this keyword that says advertise. Now, after this advertise, I have a few options. What I'm looking for is the map, because I need to do an advertise map. And I'm just going to use the name of my route map. So I'm going to say advertise. Now, after this, I have two options. I have either exist or non-exist. So in other words, for this particular neighbor, I want you to advertise whatever's in my advertise map only if this prefix exists or doesn't exist. And so obviously I'm matching the exist map at the moment. Okay, so I'll go ahead and say exist. Do show run section router BGP. So very cool feature. What I'm going to do is I'm going to go ahead and I'm going to advertise my 192.168.1.1 that's in this route map only if I have a route to the network that exists in this exist map, which is 10240. So let's say do show IP BGP, and we should see 10240 and the next hop as R2. So let's say do show IP route BGP. So do we have a route to it? 10240, yes we do. So what we're going to do here is I'm going to go on to R2. Now remember that this has nothing to do with the adjacency between R1 and R2. So this adjacency here, let me just pick a color here. This adjacency right here is functioning perfectly well. We don't have any problems. In fact, all we're going to do is we're going to remove this prefix here, essentially our route to Google. Okay? So what we'll do is we'll say config T, config T. I'm going to say interface 01, and all I'm going to do is shut it down. We'll wait for the console message to come up letting us know that we've shut down the interface. I'm going to say do clear IPBGP star soft out. I'm going to head over to R1, and I'm just doing this to clear the process faster because I don't want to wait, the advertised interval here for BGP to clear out. And of course, you and your production network, you may want to change those intervals. Let's say do show IP BGP, and let's see if the 10240 still exists. It no longer exists. Let's say do show IP route BGP. We no longer see the 10240. Let's go over to R2, and what I want to do here at this moment, if we scroll up here, let me scroll up. We had the 192.168.1.1 in our routing table, or I'm sorry, in our BGP table. Let's see if it's there now. Show IP BGP, and we no longer see it. So the 192.168.1.1 disappeared. The rest of them did not, because we did not add them to our advertise map, right? If we go in and I say do show run section route map, this was an advertise map, right? So if I say do show run section access list, and I look at the two ACLs that I created, this was the exist map, right? So access list 1, I was looking for this particular network to exist. It didn't exist, and so what did we do? We stopped advertising whatever matched ACL2, which was that individual network. Again, if I wanted to add all of them, I could have done so. Now, what we want to do here, let's say show IP BGP on R3, we are seeing the 192.168.1.1. So what we want to do here is we only want this prefix to show up in the BGP table or the routing table of R3 if and when this disappears. So we don't want it to show up on R3 all the time, only when the route to that network disappears. So let's go back into interface E01. We'll go ahead and say no shut because we want it to come back up. We'll say clear IP BGP star soft out. We'll go on to R1. We'll say do clear IP BGP star soft. So now let's go ahead and let's build the opposite of this, because if I go over to R3, you can see that I am getting a route, or I am getting a prefix in my BGP table for 192.168.1.1. So what we're going to do is, again, we're going to build the opposite of this. Okay, now I am going to build an exist map that essentially matches the same one that I've already built. It's going to be the same ACL. The only reason that I personally am going to build another one is because of the name. I like to name my route maps very, very specific to what they're doing. You know, in the production world, if I had dozens of route maps, I would obviously clean this up a little bit and make it more, make something that I could use, in both scenarios. And I could still use this. It's just giving you guys more clarification. I just want you to know that I could use the same route map because essentially I'm looking for the same exact condition. Okay, so do show run section router BGP. The difference is not the route map. The distance is in the command here, whether it's exist or not exist. Okay, I like to have my route maps very specific. So if I have an exist map, I like exist. If I have non-exist, I like non-exist, even if that's looking for the same prefix. Again, not to beat a dead horse, you could certainly use the same route map if you wanted to. In fact, you could use this same exact command, simply setting this to non. So for example, if you really wanted to, you could go in and do this. And all you'd have to do is basically do non-exist. And this would work just fine because you're advertising the prefixes using the same route map. I just don't like it. Okay, so I just want to make that clear for you guys that might be saying, why are you doing all this? So let's say do show run section route map. Okay, this is my personal preference. I'm going to say route map and say non-exist, permit 10. And all I'm going to do is basically use the same exact ACL. Exit. Do show run section route map. Okay, there we go. So I have two route maps, exactly the same. Only difference is the actual name. Okay, do show run section router BGP. Let's go into our BGP instance, and I'm just going to basically copy this. I'm going to copy this up to this point, and then what I'm going to use is the non-exist. And then what I'm going to do is simply take this name of this route map, which again is looking for the same exact prefix. They're both matching ACL1, which if we scroll up, should be up here somewhere. Where was it? Yeah, so if we look at ACL1, it's saying, look, if this does not exist, then I want you to advertise this prefix to this neighbor. Okay, so let's say clear IPBGP star soft out. Let's clear what we're advertising. Let's go ahead. Actually, we'll say soft, and let's go to R2, and let's say soft. Let's go to R3, clear IPBGP star soft. Let's give it a minute. Let's say show IPBGP, and we see, basically what we expected. The 192.168.1.1 has now disappeared, but the 1.2 and 1.3 still exist. Let's go over to 2 and say show IPBGP, and you can see here that we have the 1.1. Okay, let's go to R1 and say show IPBGP. Let's see what we have. And here's our 240, right? 10.240. So now what we want to do is we're going to go over to R2. We're going to shut down this interface to stop this prefix from advertising and simulating that somewhere in our service provider network we have a problem. Again, don't forget that this adjacency is fine. We might still be getting other routes to other production websites out there on George Bush's internets, but, for Google or for something that's production that we really care about, that we really need, for some reason, our service provider has stopped advertising that prefix to us. Okay. So, let's go ahead. Let's go to R2. We'll say config T interface E01. Whoops. Interface E01. And we'll go ahead and say shut down. We'll wait for the console message to come up. Clear IPBGP star soft. Out. Let's go over to R1, clear IPBGP star soft. Give it just a second. Do show IPBGP, show IPBGP, type the right command, knucklehead, and there we go. So no 240. Let's check 2. Show IPBGP. We're going to have to clear this again. Clear IPBGP star soft. Let's say show IPBGP. And there we go. So the 1.1 has disappeared. Right now, this would automatically time out, guys. So don't think the question in your mind right now. Yeah, but our service provider is not going to clear it, and would I have to call my service provider? No, you wouldn't. This would time out on its own. I just don't want to sit here and make you guys wait watching the video, and I'm way too lazy to do video editing and fast forward. So let's say show IPBGP, and now we see the 1.1. So when we were up here, we did not see the 1-1 in our BGP table, but down here we do, because it's based on our conditional advertisement. It's based on the condition that we've met, that this prefix here has now disappeared from our BGP table. And so since it's disappeared, we no longer can get to it. We no longer have a route to it. And what's going to happen is R1 is now going to advertise our prefix that we've selected over to R3. Once this comes back, we will stop advertising it from R3 and go ahead and re-advertise it out to our production service provider. So again, one of the very, very cool features to me anyway in BGP, the conditional advertisement. Make sure that you guys practice this a lot because it's something that I personally love to see being used.